Hi, my name is Bharat Satarman. I'm the product manager for Pivotal Greenplum Text, aka GPText. Today we'll be talking about GPText 2.0, which is the next iteration of Pivotal's text analytics for big data.
First little disclaimer. So what exactly is GPText? Essentially, if you think about organizations today, text is ubiquitous. You see it in medical records, emails, social media, recommendations that people write. It's everywhere. And it's starting to fast become the new hot topic. How do we process text? How do we analyze it similar to human scale? Because people may be able to talk to one another easily and understand colloquialisms and different languages and slang, but computers are still catching up in that sense. And what GPText aims to do is enable organizations to process this mass quantity of raw text data for large-scale text analytics. So basically, we support semi-structured as well as structured data given social media fields, email databases, raw documents, etc. We want to be able to search through that and join it with whatever other structured fields and metadata that might be associated with the document. We integrate Greenplum's MPP database architecture with Apache Solr Enterprise Search, and by extension, we have some integration points with the MATLAB Analytics library. So we leverage MATLAB for that statistical machine learning, whether it's clustering, sentiment analysis, regression, classification, etc. And we also essentially take the Apache Solr libraries, run them on top of the GPDB architecture, but we expose it all as SQL UDFs. So you have a simple, easy-to-use interface for both your indexing, search, and your analytics functions. So what's new in GPText 2.0? We have a couple major highlights. Most of all is high availability on the same order as Greenplum. So we can handle cases where the primary segment fails, where the primary Solr instance fails, or even both. We wanted to make sure that GPText was fully operational given any sort of downtime, especially in these business critical applications. So in case an instance did go down, you would still be able to index your data. You would still be able to search through your data and be fully operational even in the most critical environments. We also made some significant improvements that we are piggybacking off of in terms of both GPDB releases as well as upgrades in Solr and Java. So we're able to handle larger document sizes than before, better memory handling when you're indexing and searching, and essentially just piggybacking off of a lot of these improvements that have been made in the underlying libraries in order to deliver a stronger and more stable version of GPText. So here's kind of a brief overview of the architecture. You have your database table, and then you have your database segments. And what GPText does is actually takes the same sort of segment configuration and creates shards, which are portions of the index that correspond to each of the segments in your Greenplum database table. And each shard essentially contains a series of replicas, which are the equivalent of primary and mirror segments that you see in GPDB. So you have a leader replica as well as any number of follower replicas, depending on the replication factor that you decide to set as part of the configuration in GPText. And essentially, these replicas get distributed across the nodes, so then you have that highly available architecture. And in case a leader replica, one of these leader replicas goes down, it automatically elects a new leader replica and continues indexing. So essentially, as long as you have one of these replicas up and running for each shard, you're still operational for GPText. And you're able to recover the replicas if need be, or in the case that they're extremely corrupted for some reason or another, you're able to easily add a new replica for any given shard and still maintain that full operationalization. So how do you configure? We essentially ported Solr, and so you get the full flexibility that you have with Solr. So you're able to do the basic configurations for memory management and general behind the scenes configuration performance tweaks that you would want. But at the same time, you have the configurability to also change how you index your data and how you search through your data. How do you want that data to be stored? So being able to change stop words, being able to change the stemming algorithms, being able to equate different words with one another using the synonyms file. And on top of that, we also added some new capabilities where you're able to equate emoticons to particular sentiments. So like a smiley face would be happy, a sad face would be sad, etc. How do you exactly define your analysis? So in the terms of the workflow, the first step, once you have your documents in your GPDB table, is to index them. And what you use are a series of analyzer chains. So analyzer chains are essentially your processing and transformation steps. So what it does is it determines the steps used when indexing a document. It's a tokenizer followed by a series of filters. So a particular tokenizer would be like a white space tokenizer to break up each document into specific word tokens. And then from there, you can either sort out stop words, which are common words such as a, and, the, of, etc. You can stem particular words. You can equate words to one another. So like GB and gigabyte could be equated to the same term, and some other ones. And what we did was we essentially took the 36 or so different analyzer chains that are available in Solr. And then on top of that, we've added two more. So one is Text International for use with international text, particularly Chinese, Japanese, and Korean characters, as well as Text Social Media. So for use with the social media fields to parse out hashtags, emoticons, short URLs, username mentions, and even other specific emoticons. So you would be able to parse them and equate them to particular terms. From the search side, we added some huge capabilities. One of the biggest things is the unified query parser. So Solr comes packaged with 3 different query parsers as one, or essentially 3 different query parsers, which are the Lucene for Boolean queries, the surround for proximity searches, and complex, which are regular expressions. And essentially, when you write these queries through Solr, you would have to write them separately and do some complicated joins or complicated query analysis in order to actually figure out how to combine those different types of queries into one. And so what we did was we took care of the heavy lifting behind the scenes. So all you have to do as a user is type in your query using any combination of the 3 parsers, and we would take care of the actual busy work behind the scenes. So here you can see in this example, GPText QP is invoking the unified query parser. And what we said was look for phrase 1 or 2 within 2 words of phrase 4 space 5. So imagine, replacing 1, 2, 4, and 5 with actual words or phrases. And so you could see here that we have a Lucene, a Boolean query, and then a proximity search. And then if you replaced one of the 4 or 5 with a regular expression, so like mobile star for mobility, or mobile phone, etc., words that have a common root, you would be able to search for all 3 types within one query. And phrases can, of course, get as complex as you want. It's only limited by your imagination. So I'll go to a quick demo. Let's see. So here I have a basic instance of GPText running. And what I'll do is quickly set up So what we're loading is essentially about close to 50,000 records of Enron data. So these are emails that were in the Enron public data set. And what we're doing is we've loaded that data into the table, and now we're creating an index. So essentially it's running through and running through that analyzer chain for this particular data set for this table and creating an index based off of that. Let that run for just a bit longer. All right, so there's that, and now we commit the index. So in this sense, it's transactional. So in case, in the rare instance that in GPText instance or GPText.indexing step might fail, you're not left in this in-between state. You need to commit the index in order for the documents to fully be searchable or start being searchable by the user. Okay, so now that we've done that, let's run through a couple queries here. So what we're doing here is essentially joining it back to the original table. So when you run through a GPText search query, you're searching the index, and what it does is it returns the document ID as well as the Solr relevancy ranking. So Solr has an algorithm for searching where it essentially determines how relevant a particular document would be to your search term. And essentially what we're doing is we're searching for Phillips Petroleum within 2 words of one another and within this date. So this is where we're talking about the being able to filter via structured data. So we're looking for all documents between January 1st, 2000 to January 1st, 2001. So here we can see some of the documents that have been returned. Which was fairly quick considering it was 50,000 documents. Now let's take another look, a little bit smaller, so you can see here what we're doing. So here what we're looking at is essentially the ID, the score, as well as who it was to. So you can stratify the documents based off of the other fields. And we're doing the similar search, but we're looking for emails to Christine Stokes in that same time range. As you can see, we have these. So let's take. Ooh, let's do that. So you can see here, this is one of the documents. And as you can see, Phillips Petroleum is contained in that search term. Now, basically, I've shown you end-to-end exactly how simple it is, basically, to, once you load your data in your GPDB table, you merely have to create the index, you commit the index, and then everything is fully searchable. And of course, as you move forward and add more documents into the table, you can change the indexing so that it only documents these, or it only indexes these new documents. So you have this sort of delta, and it's very iterative, and you don't have to do a full reindex every time you add one new document into your table. Now let's take a look at GPText state again. So as you can see here, we have our index name and the state as green. So what this means is essentially we have made it simple for any sort of DBA or any user to see exactly the state of their system, of their GPText instance. And we have three particular states for each index: green, yellow, and red. Green is all your replicas are still up, your index is fully operational, everything is completely fine. Yellow means some of your replicas may be down, but you still have one replica available for each shard. And that means that you're still operational, but it's just warning you that you may need to check out what's going on in your system just to avoid any further failures. And red means, which is a very, very rare instance, and that usually happens only when multiple hosts go down. And you probably would have bigger problems than just GPText at that point. But red would essentially mean that some of your shards have lost all of their replicas, and you would need to reindex. Now, what we can do here is essentially take a look at the Solr instances, and let's kill one of them. Okay, so as you can see, that Solr instance is gone. Let's wait just a little bit. And what this is, how we're getting the state and the configurations is we use Zookeeper in order, in addition with the Solr cloud architecture, we use Zookeeper to manage the configurations as well as manage the cluster state. So now if we take a look, it tells us which node is down and exactly what state it's in. And so we can see here that it's in a yellow state, which means that it's still operational. And I can prove that to you just by using, by showing this. Let's see. Let's do one quick thing. So I'm loading some of the configurations, so you can change some of the configurations here. And what we're doing here is we're just setting the failover factor. So this is one of the configurations essentially to determine, and this is a more of a precautionary measure. The failover factor essentially says as long as X%, in this case 40%, which is value from 0 to 1, as long as X% of your nodes are still up, you can continue to create new indexes. And the reason why we add that sort of precautionary measure is if all but one node are gone and you want to create a new index, all the replicas are going to be stored in that one node. And in case that node goes down in the future, that whole index is gone. So what we want to do is maintain that sort of distributed architecture, that high availability, and we give the user that flexibility to determine how many, exactly how much of a leeway they want when creating new indexes, and how distributed they would want their new indexes to be in the case that any node does go down. So let's do this. So we can do this. What I'm doing is just creating a basic table. All right, so created the index, we've indexed. Now let's commit that index, and everything is good to go here. And now when we take a look at GPText state, you can see that, yes, our existing instance is still yellow because some of the replicas are gone, but this one is green because it created all the replicas on a healthy host. Now, how do we recover? It's simple. We just do a GPText recover. It checks the state, checks which instances are down, and attempts to bring them back up. Just a bit longer. All right. So now, if we check the state, you see everything is green again. And as you saw, like even when some of the instances were down, you were still able to create a new index and index that data, and you would still be able to search through it. So as you can see, these are some vast improvements in high availability and stability that really make GPText a much more robust and stable architecture. And as we continue to move forward, we're going to build on that stability, build on that performance, and add new features to really make GPText the text search and text analytics platforms that our users would want to use and interact with. With that, that's it. Thank you so much for joining this GP chat, and looking forward to talking to you soon.